Good afternoon, students. The video got interrupted, so that I have divided that is into the part A and part B. In continuation to the part A, the part A the video got interrupted at the time autocorrelation function. The autocorrelation will be defined in the same random process. Here x of t is a random process in which we will be choosing the sample functions are small x of t at the instant of t1, small x of t2 at the instant of t plus tau. So average of these two sample functions, will be the time autocorrelation function of that x of t, where x of t is what? Capital X of t is a random process. Autocorrelation Rx of tau is nothing but it is a mean of product of the two sample functions x of t and x of t plus tau, sample functions, and it is nothing but it is a density function. Average of x of t is a density function into x of t plus tau, it is another density function. Product of average of product of these two density function is called as the autocorrelation, and it is denoted with Rxx of tau, which is equals to limit t tends to infinite 1 by t integral minus t2 plus t x of t into x of t plus tau into dt. That means what? The autocorrelation will be within the same random process. This is one sample function and this is another sample function, and for these two we will be calculating the mean, that is nothing but average function, and that is also named as autocorrelation function. In this equation, if you go with the tau is equals to 0, in this equation if we go with the tau is equals to 0, what happens? Rx of tau is equals to limit t tends to infinite 1 by t integral minus infinity to plus infinity x of t, and it is also x of t because tau is equals to 0. X of t into x of t, it will be the x square of t, so that if tau is equals to 0, the time average function is given by a into, here it is both, here only one sample function is there, but here the two sample function both are same, so that it will be x of a of mean of x of t into x of t, that will be a x square of t is equals to limit t tends to infinite 1 by 2 pi integral minus infinity to plus infinity x square of t dt. This is called time mean square function. Without having a square, it is a mean function only, but we are squaring that so that we can call it as a time mean square function. Here the point is very clear. It is to be noted that autocorrelation function within the same random process, whereas time cross correlation function between the two random processes. Here we will be having the two random processes. One is x of t, another one is y of t. X of t is a capital X of t is a random function, and capital Y of t is another random process. In first random process, that is x of t, we have defined one sample function that will exist all the values of t, and here y of t, small y of t is a sample function in a random process that is about y of t. These two are what? Sample function. These two are the sample function. So that time average product of x of t into y of t plus tau will be the cross correlation function. Cross correlation between it is a correlation between the two different random processes and the two different sample functions. so that the mean of those will be given as a cross correlation r of x r x y of tau is equals to limit t tends to infinity 1 by 2 t, it is 1 by 2 t integral minus infinity to minus t to plus t x of t, and here y of t plus tau. This is nothing but it is a cross correlation function. So that just now I have explained the time average function and the autocorrelation function, time mean square function and time cross correlation function, and this is 4 types of function just now we discussed. And the next one we will be going with the another function that is nothing but it is we will be going with the another with these 4 functions the time functions will be completed. Then we will be going for the another slide that is going to explain the ergodic processes and the ergodic theorems that will explain us. This ergodic theorem or ergodic processes is very very important in the examination point of view, so that everyone must be careful about this ergodic process or ergodic theorem. So this ergodic process is going to be very important in the examination point of view. I am going to explain this ergodic processes or ergodic theorem so that you can able to attend the all the things which are going to there in the exam in the ergodic processes. So ergodic process is nothing but here it is the statement is given by the ergodic process, or the sometimes we can call this is ergodic theorem also. See, the ergodic theorem states that for any random process x of t, all time averages of sample functions of x of t are equal to the corresponding statistical or ensemble averages of x of t. That means what? Here x of t is what? It is a x of t is nothing but average of the sample function. Small x of t is small x bar is nothing but it is a average or the mean of the sample function, whereas capital X bar is nothing but it is a mean of the random process. If the average of the sample functions at all the values is equals to average of the random process at the all the values, then that will be called as ergodic theorem. It is very very simple that here we can go with the 2 statements for a ergodic theorem. First one is about small x bar is nothing but a mean of these sample functions at all the values is equals to mean of the random process at the all the values, that is from t is equals to minus infinity to plus infinity. I am going with the statement of the ergodic theorem. The ergodic theorem states that for any random process x of t, all the time for any random process x of t, we will be assuming here the random process is x of t, and all the averages of sample function, this is the averages of the sample functions which must be equals to the corresponding average values of a random process. Capital X is what? It is a random process, and the small x is what? It is a sample function. So that averages of sample functions must be is equals to corresponding statistical averages of the random process. This is about the mean of the sample function, and this is the mean of the random process. In the correlation process, in the autocorrelation process, we can write this is about we can write the autocorrelation of the samples is equals to autocorrelations of the any two sample functions is equals to autocorrelation of the complete random process. This is nothing but it is a statement of the ergodic theorem. Sometimes we can call this ergodic theorem is also ergodic process. Random process that satisfies the ergodic theorem is called the ergodic processes. That means what? If you are having the random process that is x of t, if that x of t satisfies these 2 statements, and then that process is named as ergodic process. This is ergodic process. Here ergodic process definition is very very simple. average or mean of all the sample functions, mean or average of all the sample functions in a random process must be is equals to mean or average of corresponding that statistical random process, that is x bar. In the correlation process, so we can define if a random process which satisfies these two conditions, and that random process is named as ergodic processes. Ergodic process is also very important. Here we will be going with the various types of ergodic processes, in which first one I am going to discuss about joint ergodic process. Joint ergodic process means we will be having the two different random processes, x of t and y of t, and the sample function which is defined in the x of t, that is small x of t, and the sample function which is defined in the random process, that is y of t, is a small y of t. So that the first condition is what? The mean of all the sample functions is equals to mean of the corresponding statistical random process in the case of x and in case of y also. And this is about what? This is about with respect to their autocorrelation function. This is Rx of tau is equals to R capital X of tau. This is with respect to the sample functions, and this is with respect to the complete process only. So that it is named as, if these two conditions satisfied by the two random processes, that is x of t and y of t, then those are named as joint ergodic random process. Let x of t and y of t are the two random processes with the sample function x of t and y of t respectively. The two random processes are said to be joint ergodic processes. Joint ergodic process if they are individually ergodic, and their time cross correlation functions are equal to the respected statistical cross correlation functions. That is, these are the two conditions. Next one is about the mean. Next one is about the mean ergodic random process. Mean ergodic random process, that is already we discussed this one. Mean ergodic random process. A random process is a random process x of t. We will be having capital X of t is a random process, is said to be mean ergodic if the time average of a sample function, this is a time average of a sample function, is equals to time average of that statistical random function, then that is named as mean ergodic random process. This is x bar is equals to capital X bar, then that is capital X bar is equals to small x bar, that is named as mean ergodic random process. I am going with the definition of the mean ergodic random process. A random process x of t is said to be mean ergodic if the time average of any sample function, this is a time average of the sample function x of t is must be equals to its statistical average, that is statistical average of the random process. That is here if both are same and the constant, we can call it is mean ergodic function, mean ergodic random process. And coming to the autocorrelation ergodic process, it is also very similar to that one only. We will be having the two sample function x of t and x of t plus tau. It is a time shift, so that these two are the sample functions are chosen in the random process at the two different instant of time, so that mean of those will be the mean of the random processes, statistical random processes of x of t and x of t plus tau naught. And here you can compare with this equation with the autocorrelation function. This is about autocorrelation ergodic process. Simple. This is one function, sample function. This is another function. This chosen from the x of t only. Then the mean of the sample functions at all the values is given by this one, and which must be equals to statistical average of the the complete random process x of t and x of t plus tau. And if you go with the cross correlation, here you have to go with x of t, and here you have to go with the y of t. That is the mean of the x of t into y of t plus tau naught. That will be named as it is a cross correlation. So that the next slide will be the cross correlation, and here you can go with the cross correlation. This is about cross correlation ergodic process. Cross correlation ergodic process. This is the cross correlation ergodic process. X of t, capital X of t, and y of t are the two random processes in which we have chosen the sample functions are small x of t, small y of t plus tau. So that the mean of those two sample products, two sample functions, and with their product mean we will be calculating. That will be mean of the statistical of those two random processes, that is e of x of t into y of t plus tau. This is nothing but it is the cross correlation ergodic function. In tomorrow's class I am going to talk about the properties of autocorrelation function and the properties of the cross correlation function. From the properties of autocorrelation and the properties of the cross correlation, we can expect one long answer question. In each correlation we have to discuss the 9 properties. With that 9 properties of autocorrelation and the cross correlation, almost the 4th unit will be closed. Thank you student, thank you so much.